Okay, Assalamu alaikum and salam jatara. We'll be moving on into a new chapter today, chapter 5, road curve. So what we're looking in this chapter is actually setting up road curve. So we will not be looking at detailed geometric design, because you'll do that later in your course. But we still have to probably discuss just probably on the surface about designs on road curve, because we need to understand, or we need to know what are the general characteristic geometric properties of the curve, so that we can set out the curve effectively. So in other words, we design the curve, then we're going to put the design on the ground. Okay. When we talk about constructing or creating new alignment of a road, we have to take into account wherever there is, or wherever there are constraints, or the constraints that we have to deal with. We have to blend in with the existing condition or other restrictions, such as properties, waterways, rivers, undulating grounds, and so forth. So for that matter, roads are not level and definitely not straight all the time. So we have to build curves. Okay, so we're going to have what we term as horizontal curve as well as vertical curve. So horizontal curves are basically curve in the horizontal plane, whereas vertical curve will be curves in the vertical plane. So I can't. All right. So in other words, okay, we can put in summary, so to say. We need horizontal curves so that our transition from one direction to another will be smooth. So let's say we're traveling in a car or in any vehicle in one direction, and then we're turning into another direction. We have to have a curve so that our journey or our traveling from one direction to another will be smooth. So that also applies to vertical curve, whereby if you could imagine you're driving up a hill, and at the end of the hill there'll be a downhill. So we still need some kind of curve at the top or at the bottom, depending which way the curve is, which way we're going, at the uphill or downhill. So we need a curve in the vertical plane, so that when we are traveling from one hill to another, from one uphill to a downhill, our driving will be smooth. Okay, what I've got on the screen now is just to show how things are done, basically. So if you like, at the bottom here on the left, let's assume that is where we want to start the work from. So let's say we're building a road from that point to this point here. Okay, and I think you can see that the area is quite undulating. You can see high ground here, lower ground. So probably in this case, the best route to take will be along the along the slope here. Okay, so the designer have decided, okay, probably that's the best route to go. So what we got to do next? We will have straights. We have. Let me change color now. Let me use green. Okay. So from that point, we have one straight going there, then another straight coming down, then another straight from that point to this point, to IP2, IP1, and finally to the end of the road. of the alignment, should I say. So having gotten the straight lines, so the next step will be to fit in a curve like that. It will be fitting in a curve. Okay, like so. So that's basically what we're looking at. We'll be looking at how to set this out. Okay, how to put it on the ground. Because we've designed it on the computer, on the screen or whatever. So you're going to put it on the ground. So that's what we'll be discussing in this chapter. Okay, so let's start by saying, okay, road curve, there are basically two types. You could either have horizontal, okay, and you could either have vertical. And horizontal itself can be divided mainly or generally into two. It's either circular or transition, whereas the vertical circle, depending whether we're going uphill or downhill. If we're going up and down, there'll be a summit curve. If we're going down and up again, there'll be a sag curve. We term it as a sag curve. So what we'll be looking at in this chapter, we'll be discussing about how to set out those curves. Okay, setting out or ranging, sometimes we call it ranging curves or setting out curve. We're going to look at what methods there are available that we can use, easily applicable, and obviously in any surveying work there'll be an element of check. So just to recap, what do we mean by setting out? Setting out is the reverse of surveying. Okay, so you've done your detailed survey, you have observed whatever on the ground, you produce a plan. So from that plan could probably be used for route design or alignment design, should I say. So based on the alignment, now the next process is to put those points in the ground. So that's what we term as setting out. So in this case, we'll be looking or dealing with setting out road curves. Okay, we'll discuss horizontal curve. Okay, then we move on to vertical. So let's look at horizontal curve first. So we could either have a simple curve, or we could either have what we call as a transition curve. Simple curve, basically a curve with fixed radius, okay, fixed radius, whereas transition by definition will be a curve with varying radius, okay, which is basically a spiral, okay, some kinds of spiral. So fixed. Let's move on to the fixed first. Let's concentrate on that one. So we could either have a circular curve, or sometimes called simple curve, a reverse curve, and a compound curve. Okay. Whereas for transition, we could have what we call as, you might have heard the term before, it's either a spiral, sometimes also called cubic spiral, or colotoid, a cubic parabola, and a lemniscate. So these are probably terms that you have came across in your geometry when you do your mathematics. Okay, let's see some example on simple curve. Okay, the top picture there, or the diagram there, shows a circular curve, a simple circular curve, meaning that we have one straight coming that way, intersect at that point, and that straight will be going down this way. So you're going to join those two straight by using what we term as a simple curve. A curve with just one radius constant. Okay? Or there will be also cases whereby we have two straights here, one there and one there. But instead of joining it with one curve, we might in this case somehow need two curves. Okay? One with radius R2 and the other one with radius R1. This could simply be in cases where we probably don't have enough ground. There's not enough room to build a curve with one radius. So we have to without with many with curve with different radii. So we call it as compound curve. And at the same time, we also have what we term as an S-curve, which is simply a curve that turns first to the left, in this case, and next to the right. I think you come across a lot of this kind of curve when you're traveling along the highway, especially when it cuts through a mountainous area, undulating area. Okay, so that's reverse curve. So we have simple, we have compound, and we have reverse. So for transition, it's a bit different here. What I have on the screen is basically to show you the differences, the different transition curve. Okay? We have cubic parabola, cubic spiral or spiral, clothoid, and lemniscate. These are what should I say, popular type, or most of the time these are the curves that are used in road design, in curve design, should I say that way? Okay, because we know we will dealing with basically with this for type of curve. Okay, we will go into that in detail when we get to discuss on a transition curve. So let's concentrate on simple curve or circular curve for now. So some terminologies before we move on. Okay, the first thing I like to discuss, I like to mention, is what they call central angle. Okay, which is basically the angle at the center of the curve. Okay, so we term that as the degree of a curve. So when I say a curve, or should I say a 4-degree curve, okay, a 4-degree curve, which simply means we have a 4-degree angle at the center with 100 unit long. So in this case, I've chosen meter. It could be any unit. Okay, so if I say a 4-degree curve, meaning 4 degree at the center, 100 unit arc length, so we will then have to find out what the radius is. So that's one way of expressing or defining a curve. So example here, if I say a 4-degree curve, we could do the calculations, use a simple basics calculation. We can find the relationship between the radius and the angle. Okay, so that's the first thing here. Degree of curvature. So when I say a 10-degree curve, so immediately you understand that it's 10 degree at the center, 100 meter long, the arc length, so we have to find out what the radius is. Okay, now the next one is intersection point and the angle theta, okay, which I call as the intersection angle. So intersection point and intersection angle. So what I have on the screen is just a map that I took from Google. So imagine there's a straight from there to there, and there's a straight from there to there. So these two straight will be joined by a curve. So that's a curve. Okay, so the angle that these two straights meet is called the intersection angle, and the point where those two straight meet is known as the intersection point. Okay, so intersection point and intersection angle. Okay, chainage. Okay. Chainage will be the distance measured from the starting point, okay, that we have chosen to any point along the road. Okay, so I think probably the best example would be, let's say you're traveling on the highway. let's consider the ones close to us, the plus highway. You're traveling up north. Okay, you will notice along the road or along the highway there'll be markers, okay, marked at every 100 meter to show some kind of distance. Okay, so those are basically what we term as chainages. So we will have a zero that we have chosen, so that'll be the zero. So the reason that we have that, so that we can identify anywhere along the curve where we are. Okay? So coming back to the plus highway, let's say that you have you were unfortunate enough to get your let's say your car broke down. Okay? Car broke down, and you call for help. And then the first thing they asked will be, where are you on the highway? So if you mention that you are near I don't know, a feature that you've chosen near a hill or near a big tree or whatever, so that will be ridiculous. So if you just if you look at the markers on the road and say, I'm at kilometer 1520, so immediately the emergency services will know where you are and can find you easily. So that's basically the purpose of a chainage, just to tell you where you are. So in terms of road construction, it will tell us at that particular point along the alignment where the curve starts. If you're talking about vertical curve, just to tell us where at that point whether it's going to be a cut or it's going to be a fill, okay, where the curve will end and so forth. So it's basically some kind of reference mark on the curve, okay, to let us know where we are, and also to give us some kind of reference when we do our construction. Okay, the location of an intersection is identified by its chainage. So the intersection point of two straights, the intersection point, for short we call it IP. Okay, so the position of those points are identified by their chainages from a chosen point. Okay, chainage can be written as for example, as if it's 4560 from the starting point, you can either write it like that, 4560, or you could, in some cases, some convention, they use this 45 plus 60. So when you do your work, when you do your marking on the curve, when you do your setting out, we normally will put markers at a specified interval. So I've chosen a 20-meter interval here. So 60, 80, 00, 20, and so on. So you could write like this, 4560, 4580, 4600, and so on. But some people and some convention, others, they prefer to write something like this, 45 plus 60, then just plus 80, 46 plus 00 plus 20 plus 40, and so on. So either way it works, as long as you understand which one that you have adopted. So it's just a matter of preference, I would say. Okay, so that's chainage, or what we call as identifying where we are on the curve, chainage. Okay, and another thing to note when we talk about chainages is that consider that's our straight, okay, and consider Z is the starting point, the 0. Okay? Whereas T and U are what we call the tangent point. So on the straight, that's where the curve starts at T, and the curve will end at U. Okay, so those points T and U are termed as, are called tangent point. So in the design, we'll be given the chainage of I. Okay, let's say change of I don't know, I just put a simple number. Let's say it's 1,000. Okay, change of I is 1,000. So, based on that number, we will calculate what the change of T is. Okay, if we know that distance, we can just take away that distance from 1,000. So that will give us this distance here. Okay, we'll do the calculation later. I'm just trying to explain the concept here. Okay, so we can calculate what the distance there. We call it change of T. Then to get change of U, we're going to add L. L is just the length of the curve. Okay, we are not going to add that distance from there. No, we're going to do it from here. Okay, we're going to do it from T. We're going to do it from T. So we're going to add the length of the curve to get change of U. To put it in a summary, change of T will be change of I minus IT, whereas change of U, the end of the curve, the next tangent point, is change of T plus L. Okay, we're not going to use I anymore because we now have information about the tangent point. Some terms or nomenclature that we adopt, we use in simple curve. I intersection point, and with where the two straight meets. Where the two straight meets are called intersection point. Point I there. Okay, and T1 will be the first tangent point, and T2 will be the second tangent point. Okay, and the distance from T to T1 is the actual length of curve. Okay, length of curve from T to T1. Then, apart from there, intersection angle is theta, so which means that angle will be theta over 2/2 of this angle here. And point P is just a point on the curve, whereas point S is the midway between the main chord. Okay, a straight line, horizontal distance, or just, should I say, between T1 to T2. So, how do we get the tangent length? That distance there, the tangent length, simply by taking the product of the radius and half tangent, half of the intersection angle. So R tangent theta over 2, and the length of curve simply using R theta. So theta in this case will be in radians. Okay, all right. So that's some simple formula, some nomenclature that we will be using in this topic anyway. All right. Okay. Now, when designer come up with alignment, so there are many factors that will be taken into account. So, in terms of the geometric design, 3 factors that I can think of that we will looking at. We will look at the intersection angle, the radius, and the velocity, or the speed that the road is designed, or the pathway is designed. So speed or velocity is subjected to the authority. Okay, so in this country, JKR, the Jabatan Kerja Raya, or the Public Works Department of Malaysia, has standards. Okay, so they put down the rule against that, regulations on that one. And apart from that, we'll be looking at the thing that we can play around with will probably theta, the intersection angle. The radius, we can, with certain restriction, we can still test a few number or try a few number, so that we can come up with what we call the best design in terms of not taking into account the geographical factor, social impact, and costs, and so forth. And then it's normally a trial and error process. You might have to do it a couple of times before you can come up with the best design as far as alignment is concerned. So there are things that we have to fix, we have to adhere, abide by, or to follow, but there are things that we can vary so that it suits the current condition.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. وايساج، معا نحو مستقبل مشرق.